Now let's move to the hands-on part. As you can see here, this is basically all the tables that we're going to look into as part of the ontology. This is a typical ER diagram. As you can see, there is private key and there is connections with the private key to the different tables that of or interest to us. So we've got like 7 tables. The main one is trips, and then you've got drivers, trucks, loads, routes, terminals, and customers, right? Now, let's go into a little bit into how we are designing this ontology, right? Uh, just to keep in mind that there is no one single correct way of doing an ontology. It's more about what you want to represent, right? In the ontology, right? What is the kind of logic you want to put into, so that you think that it's better, like for your team, etc., to understand more about it, or the business stakeholders, etc., right? So there's no right answer here. It's just that you are designing this ontology by keeping this logic in your mind, right? Now, as we discussed previously, we have 7 tables and then 7 primary keys. Also, now this is actually the core ontology part. These are called as links or whatever. The idea is you have a concept of noun, verb, noun. Okay, you're basically identifying logic in this aspect, right? So you're connecting 2 different tables. In this case, let's say trip moves load. You're connecting trip and load table. Trip has driver. Trip makes trip. Sorry, truck makes trip, and trip follows route, and then route originates with route has a origin terminal, and route has a destination terminal, and loads works for a customer, right? So you're combining all these different tables with some sort of verb. The exact verb doesn't really matter. All that matters is few things. Okay, the first thing is you got to pick a primary key in one table, and then you got to pick a let's say a foreign key, right? So the primary key of one table has to be a foreign key in the other table. That's the important thing. That's how you're basically connecting them. And the second thing is, yeah, the second important thing is, what is the type of connection? Is it a, are we saying it's a one-to-one kind of relationship, or is it one to many, right? So, sometimes you would see, as you can see here, the A to B is one trip, one load, right? When you have a trip, you can have one load, or you can have one trip has one driver. I mean, in this particular case, we are saying it's one driver and one trip, one load. Some other, different use case might have different loads. Let's say if you're a last mile delivery driver, you could be having multiple loads, right? We are not taking that. We are saying, we are assuming that this particular use case, only one trip has one load. So that's a one-to-one relationship. On the other hand, there are one to many or many to one relationships. So for example, one origin terminal can have multiple routes, even as per our data, right? This is the logic that we are basically going to embed into the ontology. Okay. Now I'm going to show you all these things in actual Foundry ontology, so that it gets much more easier to visualize for you. And then finally, we're going to see what is the exact insights that we can draw. Like, what is the point of doing all of this, right? Understanding the point of building an ontology is the most interesting part, in my opinion, because that gives you a sense of achievement, right? You've done all of this, new data structure, and ultimately you got to gain something, isn't it? Like, that's, you will see that. Just give me a minute, guys. Okay, now basically, okay, let's just go to Ontology Manager. Okay, so as you can see, this is an Ontology Manager. Now, what I've done here is I've created a lot of objects on the Ontology Manager, right? You have different object types: customers, drivers, loads, routes, terminals, trips, etc. Now, each of this, I'm not going to like show you how I did that. That you can maybe check a different video to how to build an ontology, but just I want to show you how I built it, because it's a little bit time taking, so we'll kind of skip that part. So essentially, you essentially is nothing but you're basically building a customer table, right? Let's say that you're calling your customer table as customers object here, and you have properties. Properties are nothing but fields, right? Fields of the table become that. And then in an ontology object, it's always very important that you put a primary key. The primary key is customer ID, and then name for a primary key identifier. Let's say customer name, right? Because that kind of tells you, hey, this is what that means, right? And that's very that's a custom that we follow in ontology declarations, right? So you have like a customer ID and customer primary key and a name of the primary key. So you will see why that makes sense. Now let's look at how actually the data is fed into the system, right? Like we discussed before, the data for the ontologists come from actual databases, right? So you got a raw layer, and then you got to do your transformations, you got to clean it up, and then you finally have like a semantic layer. In this case, because there's not much data to begin with, I mean, the data is clean to begin with. You don't need to do a lot of cleaning. You just need to do a little bit of transformation. So for example, let me show you what I mean. So you have customers data here. In the customers, we have customer ID, name, string, contact name, etc., etc. Yeah, one thing to keep in mind is when you're designing an ontology, you can't have arrays or structs, right? So that's one thing you need to keep in mind. So this Excel sheet that we saw previously, I mentioned it here. So I've checked all the data and then saw that this drivers table had something called CDL endorsements, which was basically an array which you need to drop that. So yeah, let me show you that. So you can have strings and you can have numbers, date, time, but you can't have arrays. So this is one thing just to keep in mind. And if you have too much white spaces, etc., you need to clean that. So we do all of that in transformations, right? So in the transformations part, we are basically dropping that columns that don't make sense. Yeah, that's no longer there, the CDL investments. And finally, you get a nice little final table, which is basically the output of that, right? Now the output is stored in a separate place in the folder, and then that becomes your backing, what we call as backing data sets. You can see this in my folder trucking. There is a output folder called customers, right? That happens to be the backing data source for this ontology, right? Okay. Now the other thing is now we'll talk about links so that you'll get a sense of what is the connections about, right? Let's go to the links. Actually, that's where it gets interesting. Yeah. So the links are basically objects that enable draft traversal. So as you can see here, what we are saying is loads connects with customer, and we have put in customer's primary key as connected with the primary key from the customers table to the primary key in loads table, which is the customer ID. Now, once you do this, you'll also have to mention the kind of relationship, right? Is it each one-on-one relationship when you are going from loads to customers, and whereas the customers to loads, you can have money, because each customer can have many loads. They could do multiple trips and all that, but each load has one customer. That's as per the logic that we have, right? Similarly, let's just quickly check the other links, right? We have destination terminal ID. Terminal ID in terminals is the primary thing. Here is the destination. Each route has one destination terminal, but each destination can have many routes, right? Okay. The other one, similarly, original terminal. So you have terminal ID from terminals, which is the primary key, and you have origin terminal ID from routes, which is the foreign key in this routes table. And similarly, we have in this A to B relationship, each route has one ongoing terminal, but each ongoing terminal has multiple routes, right? That's pretty much it, right? So you have here, it's a one-on-one. Some of the data types are like that, right? Each trip has one load, and we are saying each load also has one trip. That's the logic we are embedding into the ontology. Okay, now what we're going to do is something really interesting, right? This is kind of the aha moment, right? Why are we doing all of this? Okay, we have just to reiterate, we have a bunch of object types and link types. The cool thing is all of those can be directly stored in your folder, right? And this is the great thing about Foundry, right? I've actually stored all my objects and links in the Foundry folder. Um, all of that have lineage, all of that have tracking, provenance, and everything. You can see yourself, they're all in your folder. And then the folder basically acts as a source for the, showing all of these data types, right? Okay, now let's do the use case. Let's build a use case, okay? You'll have to go to EIP assist agent bot, okay? So once you do that, what happens is you can actually create an agent. I've done that already, right? So this is your typical agent, right? You have different settings here. I put an instruction to the agent saying that, hey, your logistics agent, these are the objects, these are relationships, right? And we've added retrieval content. In the retrieval context, you're going to have to add all your ontology objects: customers, drivers, loads, routes, terminals, trips, and trucks, right? Once you add all of this information, the agent basically gets a context and it is able to answer questions that you think are relevant. And this is where it gets really interesting. Why are we building the whole ontology thing, right? Okay, so I think you don't need to worry about other things. If you want to, these are all additional features and knobs. You don't have to worry too much about it. Let's just go and have fun with our agent, right? So we are saying, hey, hi. I just say hi and it says, hi. Okay, it just said hi. So I have a context of all these tables and we already have connected them, right? So we can ask a question like, hey, let me ask a question. Okay, which routes carry loads for most customers? Okay, so it's able to basically, this is the beauty of this, right? We haven't written any SQL query. It's taking all the information using the context, and then it's essentially giving you all this, data. So it's beautiful because it's able to connect different tables directly without you telling it, right? It'll. I'm asking it, okay, what is the logic? How you got this information, right? Let's see what it says. Okay, I think I need to just retry because this might have a throttling. Let's ask the next question and see if it works. Yeah, so this answer this question. It said I'm using this following relationship. I'm sorry guys, there is some issue. Let's just go back to the previous ones, the questions. I think they're already there. Okay. Yeah, so I think it's gotten some sort of API rate limit or something. So I've asked this question: which customers ship to the most destination terminals? It's given you this information, as you can see here. Bayou Chemical Supply ships to Dallas Hub and Denver's Hub, etc., etc. All of this information. Yeah, no single customer leads outright in the provided data set. The maximum is 2 destinations shared by the 25 customers. So it's saying there's no one who's like the most used sort of thing. So it's giving that information, which is wonderful. Which drivers delivers loads from the largest number of customers? It's giving you that information also, right? Kimberly loads delivered a cascade product, blah blah blah. Several trip record reference driver IDs that are not present in driver master data provided, so I can only name drivers where both the trip and the driver records are available. If you want, I can produce a driver to customer tapping table for all the match records. So it's basically behaving like your typical LLM on ChatGPT, right? Except it's using all the data that you have provided with all the context of the data, all the connections that you have made for the data, right? This is the power of ontology, right? Um, Now there is another application called Workshop, which we are not going to talk about in this session. We'll probably cover this in the next session. But essentially, Workshop is a tool that you can actually use to build your own charts and graphs and all that, and you can do your own um, custom SQLs as well instead of relying on a bot. Because the bot is very good for business users to get a sense of things, but if you want to build complex charts, Workshop is the one to go. Okay. With that said, let we'll conclude our today's presentation. Thank you for join. Thank you for paying attention to this masterclass. And if you have any questions or comments, feel free to put them in the comment section. Thank you.